Hello viewers, in last video we have seen about how to find the IDFT for a given sequence using DAF FFT algorithm. Today we are going to see about how to find the output of an filter whose impulse response is h of n is equal to 1, 2, 1 and the input signal, that is the sequence x of n is equal to 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1, 2, 5, 3, 1 using overlap save method. The question may be different, that is either the question may be in the form to find the output of an filter or perform the linear convolution for a finite samples for the given impulse response or for the input signals using overlap save method. There are three different steps involved in computing the overlap save method. That is, the step 1 is in step 1 you have to find the output sequence. Let be the length of the output sequence. Let k be the length of the output sequence, that k is equal to the length of the input sequence plus length of the impulse response of the system minus 1. So this is the step 1. Step 2, we have to subdivide the input sample into smaller subblocks. That is a subdivision. Subdivide the input signal into small subblocks. So how to divide the linear sequence into small subblocks? That is, you have to divide into, that is in terms of the L be the length of the smaller subblocks, that it should be greater than or equal to m. Okay, the m is nothing but an length of the impulse response of the system. Then what should be the content? That is the step 3. What should be the content in the step 3? So it should contain L minus 1 sub-block sequence and m minus 1 previous terms or past terms. In first sequence, the past sequence is 0. And the remaining thing is the L minus 1 input sub-block sequence. And for x2 of n, within the last m minus 1 terms of the first sequence, and the remaining bn L minus 1 sub-blocks. Okay. In the last step, that is a step 4. Step 4, you have to do the circular convolution. That is, y1 of n is equal to x1 of n circular convolution of h of n. Okay, like this you have to do it for the n subblocks. That is xn of n circular convolution of h of n. Then the last step is, that is a step 5. The last step 5 is you have to discard, you have to add, or you have to add the, that is addition of the sub blocks. That is, you have to discard the m minus 1 past terms, m minus 1 past terms in the each subblock, and write the remaining samples as it is. So these are the steps involved in computing the overlap save method for a given input sequence. First you have to find the length of the output sequence, then divide the input sequence into smaller subblocks. Each subblock should contain L minus 1 terms, that is the input samples, and m minus 1 previous past terms. In the first subblock, it should contain past m minus 1 points and the remaining the terms in the input sequence. For the another upcoming sequence, it should contain n minus 1 subblock previous term and l minus 1 input sequence. In step 4, do the circular convolution with the input subblock and the impulse response. Then in step 5, add that is add all the subblocks and discard the m minus 1 pass terms in each subblock. See, here the input sample h of n is equal to 1 comma 2 comma 1. The length is m is equal to 3, and the input sequence x of n is equal to 3 minus 1 0 1 3 2 0 1 2 1 2 5 3 1. The length of the sequence, that is L S, is equal to 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So the step 1, we have to find what should be the output of the length of the sequence after linear convolution. That is the length of the output sequence bx. So ls plus m minus 1, which is equal to 14 plus 3 minus 1 is equal to 16. So k is equal to 16. It is the length of the output sequence after linear convolution. This is a step 1 over. Step 2, we have to divide the lengthier sequence into smaller subblock. So for this, you should choose the L value. What should be the L value? L value should be greater than or equal to m. That is, L should be greater than or equal to 3. So I am taking L value as 3. Then divide the lengthier sequence. Divide the lengthier sequence into smaller subblock. That is, each subblock should contain, that is the step 3, each subblock should contain 3 L minus 1 subblock. That is, I am divide each subblock into 3 3 3. Okay. X of n is equal to 3 minus 1 0 1 3 2 0 1 2 1 2 5 3 1, and divide by into 3 3 1 3. I am divide the lengthier input subsequence into smaller subsequence. Okay. So that is a 3 3 3 3 and 3. Okay. Next, I am going to write each subblock. That is a step 4. So to write the lengthier sequence, so it should contain L minus, that is the m minus 1 samples, that is the 3 samples, 3 minus 1 0, and L minus 1, that is the x of 0 to m minus 1, x of 0, x of 1 and x of 2. And then the previous term should contain m minus 1 previous term. M minus 1 is 3, 3 minus 1 2. So the previous past term is 0 and 0. So this is the first term to write the input sequence. The second sequence, x2 of n, that is the first two sequence should be the previous terms, that is the past term, minus 1 and 0, and similarly the next subsequence 1 comma 3 comma 2. So this is for x of 2, and then x of 3 is equal to what is the previous term is 3 comma 2 comma 0 comma 1 comma 2, and then x of 4 is equal to The previous term, 2 term is 1 comma 2 comma 1 comma 2 comma 5, and then x of 5 of n is equal to, the previous term is 2 and 5, and then 3 comma 1 comma 0. See here, when to write the final output sequence, you have to discard the m-1 term. That is, you have to discard the m-1 term. So by subdividing the lengthier sequence into each sub block, so you have the element as an, if you discard the m-1 term, after discarding you will be getting 3, that is a 3, 6, 9, 12 and 15. That is, you need the final sequence is 16. So when you discard the first two term, the remaining element will be an 15 element. That is, one element is missing. So that you have to add the previous term, that is x6 of n is equal to, the previous term is 1 and 0. The remaining thing you have to put it as an 0. So when you discard it, you will be getting the total length of the sequence be an 16. Okay. So we have subdivided the lengthier sequence into smaller sub blocks. Okay. Next step is you have to do the circular convolution. That is, y of n is equal to x1 of n circular convolution of h of n. So you know very well about how to do the circular convolution. The circular convolution, the length of the two input sequence should be in the same length. So we are going to take circular convolution for the sub block x1 of n and the h of n. Okay. Here in this we frame the matrix for h of n. That is a circular convolution form. Okay. That is the circular convolution form of h of n. That is the, you know that h of n is equal to 1 comma 2 comma 1. So it is of length 5 and x1 of is of length 5. So you have to add zeros. Okay, the circular convolution for h of n is equal to 1, 2, 1, 0, then past term 0, 1, 2, 1, 0, 0, 0, 1, 2, 1, again 1, 0, 0, 1, 2, again this 2, 1, 0, 0, 1. So 5 cross 5. Okay, why we have chosen the h of n means, so h of n is a it is a fixed one, whereas x of n is we are going to compute the circular convolution for different subblocks. So h of n is a fixed one, so that I am writing the h of n is in the circular, that is a matrix form. So to find y of n, so write the circular form matrix, that is 1, 0, 0, 1, 2, 2, 1, 0, 0, 1, 1, 2, 1, 0, 0, 0, 1, 2, 1, 0, 0, 0, 1, 2, 1. And the length of the input sequence, first one is 0, 0, 3, minus 1, 0. A simple matrix multiplication. So what is the value for this? Just multiplication. 1 into 0, 0, 0 into 0, 0, 0 into 3, 0, 1 into minus 1, 2 into 0, 0, so minus 1. And similarly, 2, 0, 1, 0, 3, 0, minus 0 and 0. And this one, 0, 0, 3, and then 0, 0. And then 4, 0, 0, 3 into 2, 6, and then 1 into 1, minus 1, 6 minus 1, 5. And then this one, 0, 0, 3 into 1, 3, 2 into minus 1, minus 2, 3 minus 2, 1. That's it, 1 into 0, 0. So this is the output sequence for the first block. Next, for second, y2 of n. So for y2 of n, the same thing, 1, 2, 1, 0, 0, 0, 0, 1, 2, 1, 0, 0, 1, 2, 1, 0, 0, 1, 2, 1, 0, 0, 1, 2, 1. And the input sequence is minus 1, 0, 1, 3, 2. The same thing, multiply it. 1 into minus 1. So you have to compute for each sub-block, that is a circular convolution between the each sub-block and the impulse response of the system. Y2 of n is equal to 60059 and Y3 of n is equal to 810,734. So similarly you have to do it for all the sub-blocks. That is Y4 of n is equal to 13, 9 minus 13, 9, 6, 6, 0. And then y5 of n 3, 9, 15, 12, 5 and y6 of n is equal to 1, 2, 1, 0, 0, 5. So we have computed the circular convolution for each sub-block. That is step 6 is, so you have to combine the output of all the sub-blocks. So you have to combine all the output of a sub-block, that is the x of n, that is you have to discard the first, you have to discard the m minus 1 term in the output sequence, that is the, so you have to write as an y of n. So you have to write all the values. Y of n is minus 1, 0, 3, 5, 1 and y2 of n is equal to 6, 0, 0, 5, 9 and then y3 of n is equal to 8, 10, 7, 3, 4 and then y4 of n is equal to y4 of n is equal to 13, 9, 6, 6, 10 and y5 of n is equal to 3, 9, 15, 12, 5 and then y6 of n is equal to 1, 2, 1, 0, 0. See, while writing the output sequence, you have to discard the m minus 1 terms in the each sub-block. The m minus term is the two terms. So you have to discard the 2 terms in the output of the each sub-block. So you have to write the output sequence. You have to write the output sequence as, that is undiscarded terms, that is 3, 5, 1, 0, 5, 9, then 7, 3, 4, 6, 6, 10, 15, 12, 5, then 1, 0, 0. The total term is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So total output sequence should be 16. You can keep the last 0 term or you can discard it. Then the final sequence is y of n is equal to 3, 5, 1, 0, 5, 9, 7, 3, 4, 6, 6, 10, 15, 12, 5, 1. Okay. So how to cross verify your answer? So we have computed the response of the filter, that is a linear convolution. How to cross verify this answer? We just cross multiply it, that is 1, 2, 1. The sequence is, that is the multiplication 3 minus 1, 3 minus 1, 0, 1, 3, 2, 0, 1, 2, 1, 2, 5, 3, and 1. And similarly 6 minus 2, 6 minus 2, 0, 2, 6, 4, 0, 2, 4, 2, 4, 10, 6, 2, and then 3 minus 1, 0, 1, 3, 2, 0, 1, 2, 1, 2, 5, 3, 1. That is the diagonal adding. The final sequence is y of n is equal to 3, 5, 1, 0, 5, 9, 7, 3, 4, 6, 6, 10, 15, 12, 5, 1. So in this way you have to cross verify your answer. We can compare with the output sequence using overlap save method with the cross multiplication, that is the diagonal adding 3, 5, 1. You just see 3, 5, 1, 0, 5, 9, 7, 3, 4, 6, 6, 10, 15, 12, 5, 1, 3, 5, 1, 0, 5, 9, 7, 3, 4, 6, 6, 10, 15, 12, 5 and 1. So in this way you have to cross verify your answer. Thanks for watching. Thank you so much.